So let's take a look at some calculations from lab number 9. So I made that video in which we had metal. We heat the metal up to 100 degrees Celsius. We dumped into a calorimeter, which is just an insulating device, and we saw the temperature of that calorimeter rise. So let's go through some of these calculations. So a few things. Again, I'll let you calculate this out on your worksheet. There's mass of metal, mass of water inside the calorimeter, initial temperature of the calorimeter. And again, this is the initial temperature of the water inside the calorimeter. Metal, again, we use the metal at 100 degrees Celsius, so we record that temperature. And then the equilibrium temperature. So after we dumped the hot metal in the calorimeter, the temperature rose. And we'll talk more about that when we go through the calculations. A couple of things when I have this raw data. I want to go ahead and calculate the change in temperature of the water. Now, the final temperature is going to be 28.8 degrees Celsius. That's going to be both the final temperature of the metal and the water, since they're both together at the end. So in this case, let's do it right here. So 38 minus initial temperature, 21.5. 17.3 degrees Celsius. So that's my change in temperature of the water. The metal, so final temperature again is 38.8. Initial temperature of the water is 100. 100.0 degrees Celsius. So I wrote a negative 61.2. You don't have to write that negative, but a negative is going to cancel out anyway because the metal lost heat. So its final temperature is lower than its initial temperature. The main thing when you're doing this, the key to this, is that the heat lost by the metal is equal to the heat gained by the water. So we can figure out heat gained by the water because we know the specific heat of water. That's a constant, 4.184 joules per grams degrees Celsius. The metal's unknown, so we're not sure what its specific heat is. That's what we're going to figure out. So I went ahead, I manipulated this equation for specific heat. So specific heat of water times mass of water times change in temperature of water. So I got specific heat of water, the mass, and then the temperature. Notice that the grams cancel out, my degrees Celsius cancel out, and I'm left with joules. When I do that, I get 2,030 joules. So that's the heat absorbed by the water, gained by the water. Now, that's going to be the same value as the metal. The only difference is, since the metal lost heat, it has a negative value, exothermic, negative 2,030 joules. This is a good application of the law of conservation of energy. Energy can't be created or destroyed, but it can be transferred from one form to the next. So now that we know the Q lost by the metal, we know the mass of the metal. This is what we weighed out initially. And we know the change in temperature of the metal. That's what we just figured out. So we can just plug it in and figure out the specific heat of this unknown metal. Notice that I'm going to end up with 0.7, what is it, 9298 joules per grams degrees Celsius. Specific heat of metals are always going to be much less than water, because metals can gain or lose heat much easier, rise in temperature faster than water. So the very last part is to figure out what this unknown metal is. Now there's this law by DeLong and Pettit in which they said that, okay, if you have 25, that's just some kind of constant they figure out, you divide it by a specific heat of the metal, you're going to end up with the atomic mass of the metal. And then I can get that atomic mass, match it up to the atomic mass in the periodic table, and they should give you what your unknown metal is. So I put 25 divided by the specific heat of your metal. Notice that the units are not going to cancel out. They just put 25 there. So I'm going to end up with 34.26 atomic mass units. So you go to the periodic table and you write down whichever element is closest to that atomic mass. I think in this case it's going to be chlorine. So even though we know it's not going to be chlorine because chlorine's a gas, always write down what your data says. The reason this is difficult, a very small change in specific heat will give you a different element. So if that was like 0.730, that would probably give me a different element as opposed to 7.298.